All right, back in week 14. And let's see, what are we writing in here? Let's highlight here. We have this coupled pendulum. And these two penduli have the same mass and the same length. The only difference is that we have this weak spring with K in between the two. And they've done a sort of a lousy job of their FBD right here, but what we would like to do is an FBD and IBD pair. And in class, I drew those, but if you weren't in class, you didn't get to see them. But what you would have received, though, from doing the FBD and the IBD pair was these equations of motion. Two equations of motion, they can be assembled into a mass and stiffness matrix, although this one they kind of cheated a little bit by bringing him to the outside. And then they solved for these the natural frequencies, and turns out the first natural frequency is just that of either of the penduli. But then the second one which is going to be a larger frequency, obviously, because you're adding something to the original one right there. So it's going to be sort of a slower type of response. The eigenvalue of the first related to the first eigenvector related to the first eigenvalue is just going to be equal to 1. So that means these things are going to move together proportionally, 1 to 1, back and forth, and in sync with each other. And then this other one says that they're going to be moving back and forth away from each other. So this just confirms what I just said. First mode, pendulums move in phase with each other. Second mode, pendulums move in opposition to each other. So here we have a example here where I just tweaked him a little bit and let him go, and you can kind of see some of the motion of this, which is representative in part of beating. Right, so we've generated another frequency going on, or actually, in one respect, you could say that the other frequency. I'm not sure if that's beating now. I'm gonna try to. I'm trying to think about that. Let's go back to this right here. Okay, so we have this example of beating, and they talk about the penduli, and here is the time history of the theta, and how that theta changes with respect to time with the solution, right? And notably, let's see, if the initial conditions are, okay, so we've moved it a amount, so that's like the amplitude in the beginning. These are the equations that sort of that represent how this thing is going to behave. So consider the case in which the coupling spring is very, very weak, and show that a beating phenomena takes place between these two penduli. We should actually probably, I should really have done, unfortunately, not doing this on my laptop, and I have a different version of SolidWorks. I should remake this thing and try to demonstrate that to you. I don't know if that's wasting too much time, but let's see if we can see that. I'll change it in a second. So consider the case right there. Now, this up above can be written from a simple trigonometric identity. Can be multiplied by these half angles. It's like a half angle identity type of relationship. You can just take my word for it. And so now we could see that when theta 1 minus theta 2 is very small, theta 2 and I said omega 1 and omega 2 are very small, theta 1 and theta 2 will behave like, right, so if this guy will get really small right there, right, so he'll kind of like disappear. Yeah, and I believe this, no, okay, so wait a minute, I'll take that back. Let me see. I can erase my own stuff. Yeah, okay. Yeah, I just want to take that back. Yeah, this will go away as well, I believe. And what we're going to be left with are these two pieces right there. So they're going to combine and make their own okay. So we have a beat frequency that gets generated based on these. I think that's what I wanted to say. I'm a little bit mathematically here. I'm a little confused of what they mean right there. I thought they just said they will behave like this and this, and then so we have this. Yeah, I'm not quite sure what that means mathematically. I should look that up, but and try to see. But let's take a look at the phenomenon against what they're saying is going to happen right here, and they're going to say we're going to have this beat from theta 1 and theta 2. Now I should mention that this is the linear displacement what I have placed onto this piece. So maybe we want to try to change the angle. So maybe I want to run that again. We're here, it's the 6-minute mark, so I'll put a pause and make a model. Or maybe I'll make a model while we're in live. What do you say? We make a model live. I can show you how fast this can be done. So we'll make a part. I'm just not going to bother with actual values. I'm just going to try to make a generalized one. I'll make it in millimeters. I'll turn the smog off. And I will say, let's see, I'll take a front view and make a sketch. I'll do it at the origin. Let me see, how do I want to do this? Do I want to do it in one thing? No, I don't need to make it in one thing. It'd be quicker. So let me just pick a value, any value. I'll go 10, and I'll leave it at that. All right, so this is going to be the hinge part of the thing. I'm going to extrude it, and I'm going to make it the mid plane, and I'm only going to make it like 6, 5. Boom. All right, I'm going to do this, make the same front plane and make another sketch, and because I'm very, very lazy, I'm going to go down to there, and that's going to be the length of my pendulum, and I'm going to make this very, very thin. Right, so I might as well give it a real length. 150 I decided looked about right. We'll make this and that, and we'll make it 4. Is that too big? That's fine. Let's extrude that. We're probably get the same amount right there. Boom. I'm going to make a hole right there. Sketch. Boom. Of course, you can make all kinds of different things yourself. We will cut that out. Extrude cut through all both. Boom. And now I want to make the mass onto it. And I'm going to make this pretty hefty onto the piece. Let me go to the front plane. Front plane. Boom. And I will make it concentric right here. Boom. To there. How big we want to make it? Oh, make it 25. That's an inch. And I'll make it a sphere. So let me cut that off. You'll get it. No, it didn't get angry. You'll get angry when I do this right here. Oh, no, I didn't get out of it. Gotta get angry when I do this. And I revolve, yes. But it recognized that's what I wanted to do. And I'm a little concerned. I'm going to check this out. Yeah, it did merge the result. Okay. All right, so here we have, I guess it's going to be good enough, right? We really wanted to make this thing small enough so that the post didn't interfere. So I kind of almost want to make it like a little bit smaller. Like maybe if we extruded it only by 2 in each direction. And what if we only extruded this by 2 in each direction? And what if we made the thing just a little bit? We made that 2. Boom. All right. So now it's got some serious mass at the end of it without being too long. Now we're going to save this, and we're going to use 2 of them. Let's see. I'll save it underneath my SolidWorks file. I already did this example, so we'll do this example again under SolidWorks and under that one, I think. And we'll just name this A. And, ooh, I forgot to do something I meant to do. So when I went to this guy right there, I want to put in a little hole. It actually didn't have to be a hole. And I'm not quite sure. Make it 1 millimeter. It doesn't really matter for our numbers, but we might want to try to change it later. Change that 15, right? So that's where we're going to connect the spring to the 2 things. Now I've changed my mind. I want to make that a little bit longer. Let's make it 50. Yeah. So it's not really in the center, but it's really out there. All right. And then we want to, let's see, I'm going to make a new one. I could probably figure out a way not to not do this, but I'm going to do it anyway. And then millimeters, and I'll go to the front plane, and I'm just going to make 2 rails. These are going to be 5 millimeters, and like I said, I don't have to do this. Make them equal to each other. And I'm not quite sure how far I want them to be apart. I'll go 100. Let's see if they interfere with each other. They won't actually interfere with each other because they won't even know the other one is there. It probably doesn't make sense what I just said, but that's all right. I'm going to make that 25. It doesn't matter. All right, so I'm going to save this as part 2B. All right, and now I'm going to create a new assembly. So these things have to be in an assembly to be able to work. And I'm going to take B and I'm going to put them in first because I'm a cheat. I gotta admit, I can't stand the what do you call it? The smog, the background. Turn it to white. All right, so now we import the other piece, assembly A. Boom. I'm gonna do it again. Insert assembly A. All right, the reason why I put B in the first place is that you'll note that you can't move these guys around. You can move this guy around. You could pick that. You could click on this and move him around, but you can't move in these. There's a thing called fix and float right here. I guess the best way to do is actually to fully establish it. So I'm going to go float. All right. So now I want to use my mates to establish where that thing is, and so I will make the front plane mated with the front plane. This is the way I like to do things. Make the top plane right to the top plane. I don't know why I have to click on that arrow twice. That check mark twice. And the right plane, connect to the right plane. Click, click. All right. So we've established where that thing is in space. Now let's put this guy onto that guy. Okay. And then put that guy onto that guy, and these are concentric. We accepted those. I'll also make the planes the same. It's nice to have it fully defined. So here's our front plane, and here is our front plane. Boom. And here is our, let's do a front plane, and then open that up, and it's front plane. So we've established this. We might want to have let's start out. All right, so here is one. This is just, we'll make them parallel. And then I'll do the same thing here. What did I say? Right plane. This is the right plane. And here. And of course, they can't be coincident. They can only be parallel. All right. So we have the established. Now they can't move at all. But we're going to now go into a motion study. And you'll note that this starts out as an animation. So if you haven't done it already, you would come up to here and go ahead and add in. And you would turn on SOLIDWORKS motion. And maybe want to click it in both places, both this left thing and this right thing, so it's on all the time. So then you'll be able to pull down and get a motion analysis. One of the first things you want to do is, okay, it already has disable key creation, also disable playback of keys, which is a good idea. We can go ahead and let's just start out with 1 second worth of stuff. So I went to the top and dragged over that black key. During that time, we're going to make sure we suppress both of those parallel things, right? So now it can actually move. We need to turn the gravity on. That's our gravity in millimeters per second squared for some reason. It's set up for Z direction, and we're actually oriented in the Y. So make sure that little green guy arrow is pointed down. Boom, we got gravity, which is really what drives these penduli, and we can pick a spring between them. Boy, I wish I can, okay, so here's one nice thing. You could go back to, not that guy, but this guy. And when you come up to, I guess you could just put a front, you could just go to front. I like to do this. We're going to sketch and put a point, and the point is going to be right there. So I like to have an actual place to apply the thing. So we're going to save it, and it's going to tell us, did you want to do that? I guess he was okay with it. All right, so I think but you'll see that that point picks up right there. And it's on both of them because we made them the same thing. Now we'll put a spring in between them. And we're going to have to maybe experiment. So here's one point of the spring, and here's another point of the spring. And that's just to display purposes only. It doesn't do anything. Here is the actual length. So you could actually adjust what the unstretched length is, but this thing already knows that they're 100 millimeters apart. I think I found that one wasn't good, but let's try it. All right. So we put the spring. So we set it all up for success. What we need to do in order for it to do anything is we need to displace one. So I'm going to displace that amount right here. And before I start, I already know that I'm not going to get enough frames per second. So I'm going to go crazy, and I'm going to make 250 instead of 25. But I only did 1 second, so I don't mind that too much. But let's see if this thing works. All right, so you can see that is a weird behavior. Boom. Let's see what happens if we make the spring less. Or what we could do instead, roll this all the way back. Let's not move it quite as much. All right, so let's see if that will. No. Okay. So, oh, wait a minute. Did I not solve it? I think I solved it, right? Yeah, okay. And you can slow this down a lot, by the way. You could go. Interesting how they just come back and forth like that right there. And, one thing we could have done, I should have done, is give it a good place for the output, right? So what we would want to do is go back to the sketch that we made and then just put another little guy right in there. I think there's a way to like make these. I've never used it to make them it's like sensor location sensors, that's what they call them. But if you want to see the behavior of this, and I put this as a displacement, linear displacement, I think I need 2 points, and let's say it's in the x direction, and I'm trying to find a good spot to do it from. Let's say it's from the origin. You know, we have the origin to right there. It will plot that. And why did it plot it twice? Oh, it's just a reflection of the thing. And then we could also do it again. And get displacement, linear displacement, x component again. Go from the origin to, get out of my way, that guy. And we can plot it on the same plot by adding it to the existing plot. And let's see what it looks like. And by the way, there's a weird, oh look at it, it's going out of phase with each other, but the overall one is in phase with each other. That's interesting. You might have to do something down here to get the values the correct. I found that you have to edit that thing. Like look at if you look at the values that are being placed onto there, they're way smaller than the other thing. But if you click them again, you'll see that they get kind of in line with each other. This is sort of they're like 100 millimeters away from each other, so we might want to make the axes the same for these two. We're plotting them on top of each other. So I'm going to go minus 120. Endpoint is minus minus positive 20. Positive 20, right? Because this one goes from negative 112 and this one goes to 12. This one always says negative. So I'll get the major units to be, I'll go by 20s, and the minor units just go by 5s or something like that. We've got to remember what we just did. Boom. And then we do the same thing for this one. And we go to minus 20. No, we went from start point. No, this was minus 120, and this is 20, and this was 20, and this was 5s or something, I think. Boom. Yeah, but you could see when they were closer to each other how much overlap, but they have about the same amount of magnitude. So let's see when we change the spring, or let's change when we change the amplitude. It might go off of the line here. So let's go back to the beginning, and it's not going to let me move it, is it? Come on. Why isn't it letting me move it? It's not letting me make a change to the thing. I don't know why. Huh. That's interesting. Let's change the spring. I don't want to mess around with this too much longer. Edit the feature, and let's make it 0.1. And let's solve it. All right, so we didn't get nearly as much in there. It would definitely change the natural frequency of the two pieces. I I'm not exactly sure why it's not letting me go back to and move this thing. That's my only way that I know to create a displacement of the piece, is to come up into it and move it. Right? Let's double check those are both killed, right? That's interesting. It was letting me do it before. Just grabbing the thing and moving it. No, it won't let me. Well, we've had a 25-minute video. Hopefully this gives you some idea of the process of solving these pieces. I showed this in class, right? Where I grabbed that thing and I moved it like crazy. Here we can only seem to, we won't able to see, oh, this to the end under there. There you go. Why can't I move it? It says move with triad. No, I don't think it moved it any further. Let's see. No, that was the same amount. Come back to the beginning. I accidentally had the auto key on. I don't want the auto key on. Let's rebuild. Oh, you know what I never did is save it. Let's do this. Go B. It's not going to let me do it. Let's get rid of those. Well, let me go back over here. Let me unsuppress and unsuppress. And now let me delete them. Or I could just suppress them here instead. Should be just as good, right? Suppress. Suppress. Should be mad at me now. How about if I go like this right here? Alright. And it's kind of weird. It's not letting me do this thing. I'm going to try it again. Now it won't do anything, right? Oh. It didn't suppress them in both places. And delete them from motion study. Delete that from motion study. And nope. How about here? Oh, there you go. Now I'm gonna go. Nope. Alright. That should establish where that thing starts. It doesn't. You're just being a jerk now. I'm just going to delete them. Let's see if this let me do it now. Now let's see if it lets me do it. No. Being a jerk. Being a jerk, you know. I'm going to do it up there now. Put it into there. Must be a way to reset this thing. A lot of times what you have to do if the thing that isn't working for you is to just start over again with a whole new study. We could actually just create a copy. Copy study right there. Start up. Nope. All right. Well, I'm ending the video because I gotta get some work done. But that's the basic idea. Damn, I hate to be defeated by this thing. So I shouldn't move it at the end. It's just going to go back to where it began. Now it's going to go back to this. There must be some way to set this up. Yeah, it was working so well before. I don't get it. Anyway, see you in the next video.